Good afternoon, my name is Kiara Zimmerman, and today we'll be talking about Module 5 lab, in which we're testing multiple carbohydrates and using Benedict's reagent to determine the presence of ketones or aldehydes. Okay, looking at my results, they were not as clear as the results that were in the, they were not as clear as the results that were in the book. Or in the lab description. So looking at that, the picture that was in the lab description, the reactions, one of them was very clearly red, one of them was very clearly yellow, one was very clearly blue, one was very clearly green, and I didn't get that sort of reaction. These are a little bit faded. It's since it's been a minute since the reaction happened, but I have a photo that I took that's included in the lab report that has a much clearer reaction, but you still kind of tell. So fructose and dextrose were my strongest reactions that had a very clear brick red color. Then came maltose, which had a brick red color, but it's just a little bit lighter, a little hazier. Lactose, I almost thought it didn't have a reaction, but if you look really close, you can see like there's some red precipitate kind of swirling around in there. So there was a reaction, even though it was very limited. And then sucrose just stayed blue, so there was no reaction there. So yeah, again, it was kind of disappointing that it didn't get those very specific, very distinct bright colors that I saw in the lab, but there was enough of a reaction for me to tell. So dextrose, fructose had the strongest reaction, maltose was next, lactose had a little bit, and then sucrose had none. Pardon me, I'm looking at my notes. Okay, so we know that Benedict's reagent will change color when it comes into contact with a ketone or an aldehyde. The reason for that is in the reduction reaction, oxidation, you'll see that the copper 2 ion that normally gives it its blue color will turn to a copper 1 ion, and that produces that nice red brick color. It's kind of explained in my lab report earlier with the drawing the glucose going to the gluconic acid. Anywho, so we know that it changes color when you have ketone and aldehydes in the compound, and you'll see that, like, well, as in my results, some of the colors showed that there was a greater concentration of color than in some of the other compounds, which shows that there was a greater concentration of ketones or aldehydes in some of the compounds versus the others. There is also a way to kind of predict this by looking at structures. A ketone looks like a double bond between a carbon and an oxygen. The carbon's got 2 other carbons connected to it. An aldehyde, very similar, is a double bond between a carbon and oxygen. Carbon has a carbon and a hydrogen connected to it. So because we know what that looks like, in my hand-drawn with IUPAC names, my hand-drawn compounds here, the clearest ones to be able to see, to be honest with you, are the fructose and the dextrose, because those had the strongest reaction. So I can point them out here. Here in fructose, you can see the double bond between the carbon and the oxygen, and then that carbon is connected to 2 other carbons, here and here. So that should result, that would be, what is this, fructose? Fructose. So that would be a ketone, and that's why we got such a strong reaction. Dextrose, we got a strong reaction, but this time it had an aldehyde. So you can see the double bond between the carbon and the oxygen. Carbon is connected to another hydrogen and to a carbon. So then you see the strong reaction there. Dextrose on it, okay, fructose. So it's possible to predict the reaction by looking at to see if there's a presence of aldehyde or ketone on there, by looking at the structure of the compounds, and able to figure out whether there's going to be a strong or minimal or no reaction at all. Okay, I think the rest of it should be covered in my lab write-up, and thank you.